All right, for 14, they're saying particles moving along the x-axis. They give a position function, and they want to know where velocity is increasing. Velocity is increasing where acceleration is positive. So let's go ahead and, well, let's see, I'll do this one graphically so that we can get an understanding of where the second derivative is above the x-axis. So that means when I use my calculator, I'll go to the graph screen here, and I'm going to have to convert to x values. So I'll have x plus 1 times x minus 3 quantity cubed. And I'm going to want to graph the second derivative. So I'll take second 8, which gives us the Leibniz d for derivative, and I'll do y2 open paren x close paren. So that's y2 of x, comma x to take the derivative with respect to x, comma 2 for the second derivative. And I'm going to go back up and highlight, oops, looks like I put it in y2, so I think that's okay though. I'm going to unhighlight the function in y2 and then just make sure in y3 I did refer to y2 of x, which was lucky. And then my graph, I'm going to do a zoom 6 because I'm looking at my answers and they're all sort of in the positive range 0 to 3 or so. So I think a zoom 6 should work just fine. And remember that I'm looking for where acceleration is positive, which is where velocity is increasing. This one is taking a while to graph. Let's see. I'm going to hit the on button. Oh, nope, I'm not going to hit the on button. Okay, recall we're looking for where acceleration is positive. So it looks like where t is less than 1 and greater than 3. And that should be answer choice D. Okay, number 15. If a and b are constants, we need a critical point at the point 1, 2. So what we're going to do is let's go ahead and type this whole function into the calculator. So I'll go back to my home screen. I'm going to use x cubed plus, remember to use the alpha a, x squared plus alpha b, and hit enter. Oops, looks like, oh no, I did do it right. Okay, I was looking over at the simplified form and it was different, but I'm good. I typed in my function correctly. Now let's take its derivative because I want to find where there's a critical point. So grab my original, take the derivative with respect to x, and I get, that's interesting, I get 3x squared, but should get 2 plus 2ax. So I'm wondering if I have something that I need to do differently here on the calculator. I'm not going to do it on the calculator because I might have something saved in one of my buttons that's making this not work, but sometimes this happens. So I go back to my work over here and I know that f prime of x equals 3x squared plus 2ax. And when x equals 1, I have 3 plus 2a. I know that the y value is 2, so 2a equals -1 and a is -1/2. So if a is -1/2, I go back to my function, my original function, which, let me change my color, I have f of x equals x cubed minus 1/2 x squared plus b. I can put that in my calculator now and evaluate it where x is 1. Let's try that to show you a little bit. So go back up to my original function, and instead of that a, I'm going to overwrite the a and put in a -1/2. Okay, so now if I evaluate this such that, remember I put the such that key at the end and plug in x equals 1, I get out b plus 1/2, and remember that my y value there is 2, so b must be 3/2. So I get a is -1/2 and b is 3/2, which does not make sense. Huh. All right, you folks, I think that there's actually not a correct answer on here. And I think the answer is that a is -1/2 and b is what I just said it was 3/2. So I think there's a problem on this key, and I'm feeling like I remember that from prior years. If anybody thinks I did this wrong, please let me know, but I'm redoing my work and I'm seeing the correct derivative here. I'm plugging in x equals 1 to get out 3 plus 2a. Y has to be 2. Subtract 3 from both sides. Divide by 2. Then I plug in over here x equals 1. I get out negative 1/2 plus b must equal 2. Negative 1/2 plus b must equal 2. So my b value is 5/2. I think the answer is, we'll just call this a negative 1/2 here, and we'll call it a.